In the farthest, coldest reaches of our solar system, far beyond the familiar orbits of Mars and Jupiter, lies a realm defined by darkness and extreme cold. Here, the ice giant Neptune holds court, a massive azure world swept by supersonic winds and surrounded by a complex system of rings and moons. It is a system that has witnessed unimaginable violence, a place where cosmic collisions have rewritten the history of entire worlds. For centuries, humanity peered into the dark, spotting only Neptune's largest moon, Triton, and a tiny distant companion named Nereid. The rest of Neptune's family remained hidden, lost in the overwhelming glare of the giant planet itself. It wasn't until the late 20th century that we finally got a closer look, revealing a graveyard of shattered worlds and reconstructed moons. Among these hidden worlds is Proteus. Discovered in 1989, Proteus is a moon that defies our expectations of what a large celestial body should look like. It is Neptune's second largest moon, yet it is not a sphere. Instead, it is a heavily battered, box-like chunk of rock and ice, a heavily scarred survivor of a planetary catastrophe that forever altered the Neptune system. To understand Proteus is to understand a fundamental battle that rages across the universe, the tug-of-war between the compressive force of gravity and the structural rigidity of solid matter. Every planet, every star, and every large moon is shaped by this invisible conflict. And Proteus sits precisely at the boundary line of this cosmic struggle, a world frozen in time. When we look at Earth's moon, or Jupiter's Galilean satellites, we see perfect, or near-perfect, spheres. This is because these bodies are massive enough that their own gravity overcomes the mechanical strength of the rock and ice they are made of. Over billions of years, gravity pulls all their mass toward the center, smoothing out their shapes into spheres. This state is known as hydrostatic equilibrium. But smaller bodies, like asteroids and comets, lack the gravitational muscle to pull themselves into round shapes. Their solid rock and ice hold firm against their weak gravity, allowing them to remain lumpy, potato-shaped, or entirely irregular. They are cosmic debris, untamed by gravity's smoothing hand. Proteus is the ultimate exception. Measuring approximately 400 kilometers, or 250 miles, across, it is widely considered to be the absolute largest object in the solar system that is not spherical. It is the heavyweight champion of the irregular moons. If it were just slightly more massive, or if it had been slightly warmer when it formed, its gravity would have won the battle, pulling it into a round world. But Proteus is made of cold, hard water ice and rock. In the deep freeze of the outer solar system, where temperatures hover just above absolute zero, ice behaves like solid rock. This extreme rigidity allows Proteus to resist its own gravity, maintaining its blocky, angular, and heavily cratered appearance despite its significant size. The surface of Proteus is a testament to a violent past. It is one of the darkest objects we have ever discovered, reflecting only about 6 to 10% of the sunlight that hits it. To the human eye, it would appear as dark as soot or charcoal, a shadowy silhouette against the blackness of space. This extreme darkness is a mystery. Pure water ice is highly reflective, like fresh snow. The fact that Proteus is so dark suggests that its surface is coated in a thick layer of complex organic compounds, carbon-rich dust, or silicates. This dark material may be the accumulated fallout from billions of years of micrometeorite impacts, slowly darkening the moon's icy crust. And impacts are something Proteus knows well. The moon is heavily battered, covered in craters of all sizes. The most prominent feature on its surface is a massive impact basin named Pharos. This crater is incredibly large compared to the overall size of the moon, spanning nearly 250 kilometers across. The impact that created Pharos must have been truly cataclysmic. It was an event so violent that it likely came close to shattering Proteus entirely. The fact that the moon survived such a massive blow is a testament to its solid, rigid structure. But the scars remain, permanent reminders of a chaotic and dangerous solar system. To truly understand why Proteus is so heavily battered, and why it exists in its current form, we have to look back at the chaotic early days of the Neptune system. Because Proteus, along with Neptune's other inner moons, is not an original member of the family. It is a second-generation world, born from the ashes of a destroyed system. Billions of years ago, when the solar system was still young, Neptune likely possessed a regular system of original moons, similar to the orderly satellite systems we see around Jupiter, Saturn, and Uranus. These primordial moons would have orbited in neat, circular paths around Neptune's equator, formed from the same disk of gas and dust that birthed the planet itself. But this peaceful, orderly system was completely annihilated by the arrival of an interloper from the deep outer solar system. A massive, icy world, born in the distant Kuiper belt, wandered too close to Neptune. This world was Triton. Triton is a giant. It is larger than the dwarf planet Pluto and makes up more than 99% of all the mass orbiting Neptune today. When this behemoth approached Neptune, it was captured by the giant planet's gravity. But Triton wasn't captured into a neat, orderly orbit. It was captured in a retrograde orbit, moving in the opposite direction of Neptune's rotation. This capture was a catastrophic event. Triton's massive gravity acted like a cosmic wrecking ball swinging through Neptune's delicate system of original moons. As Triton's orbit slowly circularized over millions of years, its gravitational perturbation sent the primordial inner moons crashing into one another. The collisions were spectacular and devastating. Entire moons were shattered into billions of pieces of shrapnel. These fragments then collided with other moons, creating a runaway cascade of destruction. Within a cosmic blink of an eye, Neptune's original inner satellite system was ground down into a massive ring of debris, a chaotic disk of shattered ice and rock. For millions of years, this disk of rubble encircled Neptune. But gravity is a patient and persistent force. Slowly, the fragments of the destroyed moons began to collide and stick together once again. Dust clumped into pebbles, pebbles accreted into boulders, and boulders merged to form new, reconstructed worlds. From this graveyard of primordial moons, a new generation of satellites was born. These are the inner moons we see today: Naiad, Thalassa, Despina, Galatea, Larissa, Hippocamp, and the largest of them all, Proteus. They are literally made from the recycled remains of their destroyed predecessors. This origin story perfectly explains why Proteus looks the way it does. It didn't form slowly from a smooth disk of gas and dust like a regular planet. It was rapidly cobbled together from massive chunks of shattered ice and rock. It is a cosmic Frankenstein's monster, a patchwork world built from the ruins of a destroyed system. Because Proteus formed so rapidly, and from such cold, solid material, it never generated enough internal heat to melt its interior. Without a molten core to soften its structure, its gravity was unable to pull its blocky, irregular pieces into a smooth sphere. It froze in its awkward, lumpy shape, exactly as it was when the last pieces of rubble fell onto its surface. For billions of years, Proteus remained hidden in the dark, silently orbiting its giant host planet. Because it orbits so close to Neptune, completing a full revolution in just over 26 hours, it is completely lost in the glare of the planet when viewed from Earth. Even our most powerful ground-based telescopes could not spot it. It wasn't until the summer of 1989 that Proteus was finally revealed to humanity. The Voyager 2 spacecraft, nearing the end of its epic grand tour of the outer solar system, was speeding toward its final planetary encounter, Neptune. As Voyager 2 closed in on the blue giant, its cameras began snapping pictures of the Neptune system. 2 months before its closest approach, mission scientists analyzing the images spotted a faint, dark speck orbiting close to the planet. It was a new moon, previously unknown to science. They named it Proteus, after the shape-changing sea god of Greek mythology. It was a fitting name for a world whose irregular, blocky shape defies our standard definitions of what a large moon should look like. Voyager 2 revealed a world covered in craters, heavily scarred, and incredibly dark. Voyager 2's brief flyby provided our only close-up look at Proteus. The spacecraft zipped past the Neptune system at over 60,000 miles per hour, capturing only a handful of blurry, low-resolution images of the dark moon before disappearing into the void of interstellar space. Since then, we have learned more about Proteus by studying it from afar. The Hubble Space Telescope has managed to capture faint glimpses of the moon, confirming its dark surface and irregular shape. But it remains a distant, enigmatic world, a tantalizing target for future exploration. Proteus represents a critical threshold in planetary science. It shows us exactly where the line is drawn between a mere rock and a true world. It is the largest object we know of that has failed to achieve hydrostatic equilibrium. It is the biggest potato in the solar system. Studying bodies like Proteus helps scientists understand the complex physics of planetary formation. It allows us to test our models of how materials behave under extreme cold and pressure, and how gravity interacts with the structural strength of different types of rock and ice. It also serves as a stark reminder of the chaotic and violent history of our solar system. The serene, orderly orbits we see today are the result of billions of years of gravitational settling. But the scars of the past are still visible, if you know where to look. The massive crater Pharos on Proteus is one of those scars. It is a record of a violent collision that occurred in the chaotic aftermath of Triton's capture. Every crater, Every jagged edge, every blocky feature on Proteus tells a story of destruction and rebirth. As we look to the future, scientists dream of sending a dedicated orbiter back to the Neptune system. Such a mission could map Proteus in unprecedented detail, revealing the true nature of its dark surface material and the deep structure of its massive craters. It could answer lingering questions about its interior. Is it completely solid, or is there some internal differentiation? How much of its mass is rock, and how much is water ice? A return to Neptune could finally unlock the secrets of this battered, irregular world. Until then, Proteus remains a fascinating cosmic oddity. It is a world that is too big to be a simple asteroid, but too rigid to become a spherical moon. It is a boundary object, sitting on the knife edge between two different classes of celestial bodies. In the dark, freezing depths of the outer solar system, Proteus continues its rapid orbit around Neptune. A dark, battered survivor of a cosmic catastrophe. A reconstructed world, frozen in time. The heavily battered moon that was simply too big to stay a shape. If you enjoy this content and want to see more, please consider subscribing. A quick tap on the like button also helps us learn what topics you like best. Thank you for watching this video, and see you in the next one.